So, hi everyone. Mm. Hi everyone. Welcome to today's session on problem solving through programming in C. So, I'm Rupesh Kumar. So, let's wait for a few more minutes so that others can join, and then we'll start the session. So, hi everyone, let's start today's session. So, the video recording, the session will be recorded and the recording will be shared with you guys. So, yeah, so I'm Rupesh Kumar and I hope I am audible. Everyone, please confirm just by typing in the chat box. Great. So, this is the way I'll be communicating with you guys. So, I will be speaking through my microphone and then you can hear me. And if you have any doubts, if you want to talk about anything, ask anything, then what you have to do, you have to type in the chat box to communicate with me. So this is the way we will be communicating for this session. And these instructions are same as previous weeks. So nothing is new. At any instant, if you feel that there is some technical issue like my screen is not visible or if my voice is not audible, then you can type in the chat box at the same time. If you face any difficulty in understanding the solution that I'm explaining, you just ask me at that moment itself in the chat box, right? Mm, mhm. So I guess Rohit has their hand raised. So Roli Kushwaha has their hand raised. So what is your doubt, Roli? Please type in the chat box. What you're saying, my assignments are pending 678. I have to complete them. Will I get a chance again, sir? So I have no idea about this because these things are managed by NPTEL team. So you can ask them, you can email them, and they will help you out with that, right? I can only help with the topics that that have been covered in the lecture tutorials, lecture videos till week 10. Fine, and I will solve some problems for you guys. Yeah. Any other doubts that you want to ask me? Please go ahead right now, or we can start the session. Right. Anyone else? Do you have any doubts? So two things. First one, please make sure my screen is visible. Second, make sure I am audible. If both of any one of these is not working for you guys, please type in the chat box right now. Right. So someone is typing something. So please let's finish up this Q doubt session and then let me start the session. Yeah. So Sharmita has some doubts. Please type in the chat box quickly so that we can resume. No one has any other doubts. So the last confirmation. I hope my screen is visible. You can see the text on my screen and then I should be audible. Anyone, please confirm by typing the chat box. Then I'll start the session. Great. So let's resume this session. So welcome to the 10th session. So this is session 10. Session 10. So it's a session from the 10th week. I'm Rupesh Kumar, and these sessions are being held every Friday, 6 to 8 p.m. Today is March 28, 2025. Yeah. So let's start with the first problem. What is the worst case time complexity of linear search? Anyone? I don't like that. Something like that. Anyone? Mm. SK Rishi is saying my skin is not visible. Is this the case for everyone? So it's visible for everyone. So Rishi, I guess there is some network issue on your guy side, technical issue. Please check your internet connection, right? So yeah. So what is the worst case time complexity of linear search? Anyone? So let's say I have some array, something like this, 8, 1, 99, Then let's call 10 here and then 100, right? Anyone? So let's say I want to search for data. So I want to search for 99, right? So how many checks we need? So everyone, are you familiar with linear search? I hope you are familiar with linear search, right? And if you want, let's say we want to search for the term 99. How will you do it? For int to 0 as less than n, I plus if array at I is equals to 99, what do you have to do? Printf found, right? This is the code that you will write for this program. What is the worst, how many checks we needed here right now for if the input is 99, anyone? So am I audible? No one is answering. So am I audible? Hello, am I audible? So you are familiar with linear search, guys, no? So let's say I want to search for the value 99 in this array. How will I start? I will start from the 0th index and keep checking for the values until I find the value. I keep check. So I will start from the 0th index and then I will keep checking until I reach the end of the array, which is index n minus 1. So you can see less than n. Now, in between, if I find the value, I will simply print that I have found the value and I will exit the program, right? So now in this case, if I was searching for the value 99, how many checks I had to do? So I had to do search from I equals to 0, 1, and at I equals to 2, what I do, I break, I exit the program, right? So how many comparisons did I take? Did it require? It requires 3 comparisons, right? Everyone, is this clear? No one is answering, so I don't know what is happening. Right. So what do we mean by worst case complexity? The worst case complexity of linear search. So first, you have to think of the worst case scenario. So what is the worst case scenario for this array? Let's say I want to do linear search. What is the element that I need to search that will give us the worst case scenario? Anyone? What do we mean by worst case? Um, what is the worst scenario? Yeah, we want to search out for the last element, right? Right. Search last element. Or search something that is not in the list. Both of them works. Or search something out of list, right? So in this case, we want to search for 100. And if we are searching for 100, how many number of comparisons do we need? Anyone? So we compared with the value at index 0, compared with the value at index 1, we compared with the value at index 2, and we searched till we reached the value at index 99, n minus 1. So how many comparisons we required in worst case scenario? N minus 1 comparisons, right? N minus 1 comparisons, right? So total n comparisons, yeah, right. The total n comparisons here, sorry. Yeah. So total n comparisons. So what is the time complexity? So what is the big O of this? So worst case is basically big O. So what is the worst case complexity of this? Order of n. Fine, everyone. Option C is correct. Option C, order of n. Everyone, is this clear? If you have any doubts, please type in the chat box. Fine. I guess no one has any doubts, right, for this problem. Great. So let's move on to the second question. What is the worst case time complexity of bubble sort? So everyone, are you familiar with bubble sort? Have you seen the video lectures? Right. So what is how do you do bubble sort? So let's say we have to sort in ascending, and we have this 8, 7, 6, 5, 4, 3, 2, right? And we want to do the bubble sorting algorithm for this, implement the bubble sort. How do we do? So we start with index 0. So we start with at index 0, 5, 6, right? So we start at index 0, and what we do, we compare the two neighboring values, right? So we compare 8 and 7. Now if we want to sort in ascending order, so we want to sort in ascending order, so we know that 8 has to come after 7, right? So we compare these two, zeroth element and element at first index, and we say that 8 is should be come after 7. So what we do, we swap them, so we get the new array elements 8, 7. Oh, sorry, 7, 8, right? 7 and 8, right? Now what we do in the next step, we again compare the index value at index 1 and index 2. So these are 8 and 6. We compare these two values. Again, we know that 8 is bigger than 6. So 8 should come after. So we swap them. So we get 6 here and 8 here, right? Again, you keep doing this. So you compare 8 with 5, then 8, you will see 8 with 4. So 8 with 3, and then 8 with 2. And what value, what is the final array after one pass? You will get 7, 6, 5, 4, 3, 2, 8. So this is the array after one pass, right? One pass. Right? This is the array after one pass. And now one thing that you can say for sure is that's the largest element data as its correct index location. That's the last index, right? Now again, what you do, you repeat the same process remaining for the remaining array, remaining part of the array, 7. So this part of the array, and you repeat those swapping steps. So comparison and swapping steps. So compare 7 with 6, then 7 with 5, then 7 with 4. Keep swapping them. 7 with 3, and then 7 with 2, and you will get 7 here, right, in the second pass, and the array will become 6, 5, 4, 3, 2, 7, and then 8, right? So after second pass of this algorithm, right? So now what you know that the last two elements are sorted. Fine. So now what you need to do? You just need to sort the remaining part of the array, right? To 6, 5, 4, 3, 2. So you keep repeating this. So how many passes will this array take? Anyone? Can you guess? So this will take 7 passes, right? 7 passes to get 2, 3, 4, 5, 6, 7, 8. Why 7 passes? So one pass for the value 8, swapping the value 8 to get it to the last value, then one for 7, one for 6, 5, 4, up to 3. So at the pass, at this after the second last pass, you will observe that you will get the value 3, 2, 4, 5, 6, 7, 8. So this will be the sixth pass, right? After sixth pass. And in the seventh pass, you will just compare 3 with 2. So you will get 2, 3, and the rest of the array, and you will get the final sorted array, right? So this is how you do bubble sort. So what is the total number of comparisons and swapping we needed here? So let's combine two things. How to define, what is the metric to define this complexity? So the metric is total steps, right? Total steps. So what is one steps? One step includes, one step includes, one step includes comparison plus swapping, right? So yeah, so for example, for 8 and 7, you compared 8 is bigger than 7 and then you swap. So these two combinedly form one step, right? So what is the worst total number of steps that you require in the worst case? So what is the worst case scenario for the this bubble sort algorithm? Anyone? If I want to sort the array in ascending order, so what is the worst case scenario input for this algorithm? No one is answering. There is, someone is answering. Yeah. Order of n square, right? How order of n square? For the element 8, you did once. It goes like this. So the correct answer is out of order of n square. That's correct. Yeah. So correct answer is option D. So let me write down the answer. For containing n elements, the worst case input for bubble sort would be, anyone? What will be the worst case input? Bubble sort for sorting in ascending order. Anyone? What would be the worst case input? That the input array is sorted in descending right? So if the array input array is sorted in the descending order, that will comprise of the worst case scenario input for the bubble sort. And for each element, you are doing how many comparisons, how many steps in this case, for the worst case input. So for the largest element, you are doing n minus 1 comparisons, n minus 1 steps. For the second largest, n minus 2, and so on up till 1, right? So what is this value? This value equals to n minus 1 into n minus 2 divided by 2, which is of order n raised power 2. Right, everyone? Is this clear? Everyone, is this clear how I am getting order of n squared? So in the last session, to help you told you guys what is worst case complexity, how to compute this. So basically, it's the upper bound function on the total number of steps that you require for an algorithm. And in this case, we see that we have worst case complexity of order of n squared. Anyone do you have any doubts? Please type in the chat box. Right? I hope this is clear. Should I move to the next question? Anyone, if you have any doubts, please type in the chat box. Should I move to the next question? That's my question right now. Great. So next question, what are the maximum number of comparisons that can occur when a bubble sort is implemented? Assume there are n elements in the array. Anyone? What is the answer to this problem? We already solved this problem in the previous session, previous problem, right? So let's say we have n elements in an array. N minus 2, n minus 1, right? So how many comparisons we require? What is the maximum number of comparisons? You will obtain the maximum number of comparisons when the array is sorted in descending order, right? And in that case, for the first element, largest element, you will compare with n minus 1 elements. For the second largest element, you would compare n minus 2 times. For the third largest, n minus 3 times, and so on, right? 1. And we all know the sum of this series is, arithmetic series is simply n into n plus 1 by 2. So n minus 1 into n by 2, right? So the correct answer is option A. So I already explained this answer in the previous problem itself. If you have any doubts, please type in the chat box. Option A. Anyone, do you have any doubts? Please type in the chat box. If you are unable to understand this problem, I can explain this. So how did we get n minus 1 and s2? Right. So let's do this again. Right. So then Lakshmi, please try to follow what I'm saying right now. Okay. So, so now let's say we have this array 6, 5, 4, 3, 2. Right. This is an array which is in descending order. Right. This is the worst case input. And the question is maximum number of comparisons. Like we want to check the maximum number of comparisons. So how to do this? You solve for the problem for worst case analysis, right? You check for the worst case analysis and you solve this, right? So this is the worst case scenario input for bubble sort, and the number of comparisons in this case will give you the maximum number of comparisons that you can do for any kind of input for this bubble sort algorithm. And for this case, n is 5, right? N is 5. So n equals to 5. So let's try to do the, let's run the bubble sort algorithm on this input and let's see what happens, right? So let's start with, let's start pass 1. So I hope you remember the bubble sort algorithm. So we start with pass 1, right? Pass 1, right? So the input we have is 6, 5, 4, 3, 2, right? This is the input that we have. I know this is the pass 1 for bubble sort. So you compare 6 with 5, right? Now you see 6 comes after 5. So you will swap them. So this becomes our new array, right? 5, 6, 4, 3, 2, right? Now what you compare? You compare 6 with 4, right? So this is how we do bubble sort. We keep comparing with the next element and swapping the two neighborhood elements if their order is incorrect. So now 6 with 4. So you see, you know that 6 is greater than 4, so it should come in the right of 4, right? So you get 6, 4, 3, 2. Again, you compare 6 with 3. So why I'm choosing 6 every time, right? No, so there might be some doubt. So it's not about choosing 6 every time. So I am starting from index 0, right? In the first pass, I'm starting from index 0. I'm comparing it with the value at index 1. Then again, I'm going to index 1 and comparing its value with index 2, right? So it's not about choosing 6 every time. It's about going through each index. That's it. So you start from index 0, compare it with 1. Then start from index 1, compare with index 2. We'll start with index 2, compare it with the value at index 3, and so on, right? This is how one pass goes, like in bubble sort. So now you know 6 is bigger than 3, so you get new array, you swap them, so you get 5, 4, 3, 6, right? Now this is the final step. So now you compare 6 with 2, and you know that 6 and 2 are in incorrect order, so you swap them, so you get 5, 4, 3, 2, 6. Now our pass 1 completes successfully. So this was pass 1. How many comparisons in this pass? How many comparisons? Then Lakshmi, can you answer me? Total 1, 2, 3, 4, right? 4 comparisons here. No, 4, right? We are not doing 5 here. Lakshmi, is this clear? We are doing 4 comparisons here. And why I'm saying 4 here? Because first you compare 6 with 5, then index 1 with index 2. So count it like this, right? Counting is oh shit, sorry. Yeah. Hmm. Right. So counting is really easy for each pass, what you're doing. So for each pass, what are you doing? So the loop goes like this. For I equals to 0, I is less than n, I plus plus. What you're doing? You are comparing value at I and I plus 1, right? So you are comparing the values at I and I plus 1. This means, so in each pass you compare 0 and 1, then 1 and 2, right? Then 2 and 3, then 3 and 4, right? So how many comparisons we did here? 1, 2, 3, 4. Like 0 with 1, 1 with 2, 2 with 3, 3 and 3 with 4, right? Then Lakshmi, is this clear? Is this visible? So we required 4, right? 1 plus this plus 3 plus 4 equals to 4 comparisons for pass 1. And after pass 1, we saw the last element, the largest element is at its correct position, right? So in pass 2, what you need to do for pass 2, you only have to do these comparisons. So for pass 2, you have the input array 5, 4, 3, 2, right? Because you don't need to compare with the last element 6. Why? So only run comparisons till second last, right? Second last element in pass 2, right? Why? Because we know that the last element has been compared with all the elements and it's at its correct position. So we don't need to do anything for that. So now again, you repeat the steps. You compare 5 with 4, right? You swap them. So you get 4, 5 here. And then 6 is already there, right? And 3, 2 are here. Then again, you compare 5 with 3, you see, and you swap them. So 4, 3, 5, 6, right? Now you compare 5 with 2, and now what you get? 4, 3, 2, 5, 6. How many comparisons we did? We did index 0 with index 1. So yeah, we compared 0th index with index 1, 1 with 2, and 2 with 3. How many total? 3 comparisons, 4, 3 comparisons, yeah. 1 plus 1 plus 1 equals to 3. So we did 3 comparisons, right? In pass 2. So when you keep repeating these steps per pass, you will see that after pass, so you keep doing this, keep reducing the length of the array, and after pass number in this program, you will see after pass 1, 2, 3, 4. After pass 4, you will observe the array will be sorted, and you will get this answer: 2, 3, 4, 5, 6. Array will be sorted. right? This should be clear. Sorted. Now what you need to do, you just, and each pass the number of comparisons are decreasing by one. So you started with four comparisons. So let's see at the final answer. You started with four comparisons. In pass two you did three. In pass three you did two comparisons. In pass four you did one comparison, right? This value can be written as 4 into 5 by 2, which is equals to 10 comparisons. Total 10 steps of bubble sort here. So 10 steps of comparison and swapping, right? So in general, if you have n elements, if you have n elements, so you can write this as just some total number of steps as n minus 1 plus n minus 2 plus up till 1. And this sum will be n minus 1 into n divided by 2, right? This is the final answer for this problem. Then Lakshya, I hope is this clear. This is clear. If you have any doubts, please type in the chat box. Right. So let's move on to the next question. So let's move on to the next question. So what are the correct intermediate steps for the following data set? Right. So we have this array and we want to apply bubble sort for this array. And what are the steps for solving this? So we already did this for previous two problems. So let's finish this off quickly with you guys. So this time I expect you guys to answer this problem with me, right? And the question is quite elaborate. It requires all the steps that you need to do. Fine. So let's run the bubble sort algorithm for this problem. The input that we have is 7, 4, 1, 8, 2, right? And we need to apply bubble sort algorithm over this array. So let's start with pass 1. So let me call P1. So after first pass, what will you get? Anyone? Can we tell me the answer? So from this, where did you go? Where do you go? Hmm. Hmm. Just a second, guys. Just 1 minute. I think the options are incorrect for this problem. Let me confirm once. Hmm. ठीक है. Hmm. So is it saying pass 1 or hmm. Okay, right. So it's not talking about passes, it's writing all the steps, right? So for this problem, we just don't need to write the answer after each pass. We have to write the total answer, right? So just start, let's do the comparisons. And let's do all the steps at once and we'll get the answer, right? So after step one, what will you get? You will get 4, 7, 1, 8, 2. So this is step one. From here, you get to the next step. So you compare 7 with 1. So you get 4, 1, 7, 8, 2. Now again, you compare 7 with 8, you know there is no swapping here. Then you compare it with 2 and you know there should be a swapping here, like, right? So 4, 1, 7, 2, 8. So now we have 8 at its right position. So this was pass 1, right, everyone? So this was pass 1. So let's move on with the pass 2. So we know that the array has not been sorted yet. So what is the pass 2? Pass 2 will start from 4, 1, 7 to 8, right? So where will we go? We know 1 and 4 has to be swapped. So 1, 4, 7 to 8, right? Then again, 7 and 4, no need swapping here. And then 7 and 2, swapping requires here. So 1, 4, 2, 7, 8, right? Now you compare 2 with 7, no swapping required, and 7 with 8, no swapping required. So this was pass 2. Yet again, the array is not sorted. So we repeat P3. We start with 1, 4, 2, 7, 8, right? This is pass 3. So you know 1 and 4 need not to be swapped, but 4 and 2 will be swapped. So you will get 1, 2, 4, 7, 8. Now, yeah, you get the sorted array, right? So once you see that no swappings are required, you end the program. So you just exit here, right? So you simply exit here. You don't need to do anything right now. The array is sorted. So these are the steps that you do. And let's see which option covers these steps. So basically, if I just compress this into one single pass, so what is the total, what are the steps? 4, 7, 1 second. Yeah. 4, 7, 1, 8, 2. You get 4, 1, 7, 8, 2. Then you get 4, 1, 7, 2, 8. Then you get 1, 4, 7, 2, 8. Then you get 1, 4, 1, 4, 2, 7, 8. From here you get 1, 2, 4, 7, 8. Right? So this is the final answer. Let's check which option matches this. So 4, 7, 1, 8, 2, right? Option, let's start with option A, 4, 7, 1, 8, 2, it matches. Then 4, 1, 7, 8, 2, 4, 1, 7, 8, 2. So this does not, it is not matching, right? 4, 1, 7, 8, 2. So this is incorrect. Like, yeah. So this option is incorrect here. Let's go on to option B. 4, 7, 1, 8, 2. This is correct, right? Yeah. So this is correct. So this is all correct. Now 41782, 41782, this is also correct. Then 41728, 41728, this is correct. Then 14728, 14728 is also correct. Then 14278, 14278, this is also correct. And then 12478, 12478. Yeah, option B is correct. Right, everyone? So I hope no one has any doubts in this problem. The answer is option B. So now Lakshmi has some doubts. Why are you confused here? You are saying I'm confused here because 8-2 is there. So what is the doubt? Can you explain? In which step you have any doubt? So what step do you have any doubt? So I will just write the steps number. So this is step 1, right? This is the output at step 2. This is the output at step 3. This is the output at step 4. This is the output at step 5, right? And this is the output at step 6. So in which step you have any the doubt, Dhanlakshmi? I thought that the pass would end at step 2. Why? So now is this clear, Dhanlakshmi? Because we already did 3 questions on this. So I hope the issue is resolved, right? Your doubt is cleared, right? Yeah, great. You won't, the pass won't end at step 2 because you go from index 0 till index n-1. You keep comparing until this. So let's move on to the next problem. What is the advantage of bisection method? So everyone, are you familiar with this idea of bisection method? Anyone, do you have any doubts on bisection method? Okay. So yeah, Dhanlakshmi is saying she wants me to answer this. Dhanlakshmi wants answer again. So yeah, let me go through this answer again, just a quick overview on this answer. So right, so you want to do bubble sort on this input 74182, right? So what you do, so you start from this value, and what are the steps that are involved in bubble sort algorithm? So you start from index 0, right? You compare the value with this index 1. Then if the values are not in correct order, just acha, sorry, yeah, I got it wrong. So yeah, the doubt is on bisection method, not in this problem, right? So yeah, let's start with the bisection method. So let's say you have some function. Let's observe some function f of x equals to x. So yeah. So bisection method is used to find roots of polynomial equations for any function, right? For root finding for any nonlinear equation, right? So let's consider this problem. Let's say we have this problem, right? F of x is given by this 3-degree polynomial, right? Is this visible? Is this clear? This is 0, this is 1, this is 2, this is 3. Great. Yeah, no, something like this. Right? Is this clear? This problem clear? So we have this function. So on the x-axis we have the x values. On the y-axis we have the function value f of x, right? And you are given the task of finding the root of this problem. So what is the value? So is the value of x such that f of x equals to 0. So for this problem, every one of you knows, like, right? The answer is x equals to 3, 2, and 1. Everyone, is this clear? So the roots of this polynomial are 3, 2, and 1. right? So how do you know this? You simply know just putting the values here, you will get the answer, right? Or the other way is just doing some just using the hit and trial method to find the first root and then factorizing the equations, remaining quadratic equation, right? Everyone, is this clear? So now you can solve for these problems very easily, right? If the polynomial is degree up to degree of 4, you have analytical equations for finding getting the roots, right? You can find the roots easily. Roots are easily obtained, right? For polynomials up to degree 4, right? So degree 4 polynomials. Okay, degree 4 polynomial roots are easily obtained. Now let's say we have some polynomial of degree 5, the easiest way I want to see. Yeah. So let's say we have some polynomial like x minus 1, so x minus 3, minus 4, 5, right? So let's say we have this polynomial. This was a really easy problem. Like you can simply use the analytical equation to get the root of this formula, right? For this polynomial. Now let's say we have this polynomial x raised to power 5. Yeah, let's consider this polynomial x raised to power 5 plus minus 15 x raised to power 4 plus 85 x cube 85 x cube minus 225 x squared 5 x squared plus 274x minus 120, right? Minus 274x plus 274 minus 120 plus 21 minus 120, right? You have this polynomial as a degree 5 polynomial and you want to find the root of this polynomial, right? Now the problem becomes tricky. Fine. Finding the root of this polynomial is really difficult. So what if we do some approximations, right? What if we want to find the roots numerically? So what is the most brute force way to find x such that fx equals to 0? So let's try brute force, right? What will you do? Check all the values of x from minus infinity to plus infinity for and stop when f of x equals to 0, right? This is not possible. Not possible. Fine. Because you can't just keep checking for all the values, all the real values. So what is the better option? If we have some intuition on the values of the root of this equation, right? What if we have some intuition on the values, right? So let's say I'm saying the roots, just a second. So f of x score equals to, right? Now plot x 0, 7. So what if I say the roots are between the values 1.5 and 2.5, right? The root one of the roots lie in the between 0.4 and 2.6, something like this, right? So I am giving you some idea. I have some idea. I say, let's say if you are given this idea, like the root of this equation, this polynomial, lie between the values 0.4 and 2.6. One of the roots, not all the roots, but one of the roots. So how to find that root, right? Then there is a beautiful algorithm, bisection method, that you can use for this problem. So, right. And then I have to erase this. And so, yeah, let's do 3, 4, 5. And I'm saying there's a root of this equation, and one of the roots lie between the values 0.4. So this is, sorry, 1.4, right? 1.4. The roots lie between the values 1.4 and 2.6, right? So I'm saying there is a value 1.4 here and 2.6 here. And I'm saying the roots lie between these two values. So we have these two values. The roots lie between these two values, right? On the x-axis. And I want to find the root of this function. So how to do this? So just let me erase this point. So the roots lie between these 2 points. So this is 1.4 and let's call this is 2.6, right? And and I'm saying the root is lies between these ranges. So we know for sure that the function looks something like this, right? It will cross the x-axis as at some point between them, right? And we want to find that point, and that point will give us our root, right? So what is the value at the we are saying there is one root between these two values. Then what is that value? And by root, what I mean f of x equals to 0. So let's call this value x star, right? And I want to find the values x star such that fx star equals to 0, right? I'm given this idea that the value lies in this range and I want to find the root. So what is the way? The bisection method says that you can, so if you apply binary search, it's like doing binary search in this search range. The ranges are 1.4 to 2.6. What you do, you search for some value in this range such that, so x lies in this range such that f of x asterisk goes to 0, right? So bisection algorithm is simply binary search on this range, and it's a continuous range. It's not discrete array elements. So what you do, you find the midpoint value. So what is the mid value? Mid value is 1.4 plus 2.6 by 2, which becomes 2 plus 1 plus 1, 4 by 2, right? Which is 2. Now check the value. What is the value of f of 2? Anyone? So when you evaluate it, it will become 0. When you simply compute the value, you will get that f of 2 is 0. So now you can say our value x asterisk is for x equals to 2, the function has value 0. So x equals to 2 is a root for this function, right? So what you did, you simply did binary search. So let's make this a bit trickier. No, I used some range that gave me answer in just in one step. So let's increase the range. Let's change the range so that we get some other value, right? So we take more iterations. So let's take the range as 1.1, 2.2, right? Let's take this range and start solving our problem. So what is the mid value? Mid value would be 1.1 plus 2.2. So 1.1 plus 2.2 divided by 2. So it will be 3.3 by 2, right? So that will be 1.65, right? Now, what is the value of f of 1.65? So when you will check this value, this value will be greater than 0, right? So I know this because I know the actual function. But if you simply on the computer, if you write this function for this polynomial, and if you check this value f of 1.65, you will find that it is greater than 0. Now let's check the values f of. So what is the 1.1? You will see f of 1.1 is greater than 0. But when you see f of 2.2, you will observe that the value will be less than 0. Right, everyone? So these are the values that you will observe for this function. Now, whenever I say that there is a root, so this means there is this x-axis, and whenever I say the root, there is a root, the function will have opposite values. So positive here, negative here, always. So whenever there is a root in this function, in this range, you will see that the function values at these two ends will be opposite, or having opposite sign, right? So if this is the x-axis, and if the function looks like this, you will get positive on the upper half and negative on the lower half. Or if the function looks like this, you will get positive and positive both sides, right? Or something like this also, you will get positive values both side or negative values both side, right? So in these two cases, the root does not exist, right? The root does not exist. But in the first case, the root exists because the values are on opposite signs. So we know that there is no root between the values 1.65 and the value 1.1. Why? Because they have same signs, right? Same sign. So now we can discard this range, and now we need to search between the values 1.65 and 2.2, right? Now you do the binary search between these regions. Why I have discarded the values from 1.1 to 1.65? Because all we saw that they have same sign. So this means the root can't lie there, right? The root will be here. Again, what you do, you compute the midpoint. You get the midpoint to be 5, 8, 19, so 1.85 by 2. So midpoint would be, sorry, 3.85 by 2. So midpoint would be 1.925, right? Now again, you will repeat the same steps. You will check if f of m, f of 1.925. So you check the values. So you check f of 1.925. This will be positive. F of 1.65, it will again be positive. But f of 2.2, we know that it is negative. So again, you can discard this region from 1.65 to 1.925. So you can discard this region and do the binary search again in this region. And if you keep repeating these steps, you will see that you will converge to the value of m equals to 2, because 2 is a root. So if you keep repeating these steps, you will get the value 2 here as the root of this function, right? So this is how you do binary search over this range to obtain the root of this function. And this is how bisection works. Anyone, do you have any doubts in this? If you have any doubts, please type in the chat box. Is this clear then, Lakshmi? Like, so you wanted me to explain this again? So you just keep repeating this step. So every time you half the range and you will get the answer, right? So what is the question? What is the main disadvantage of the bisection method? It is computationally expensive. No. Why it is not computationally expensive? Because every time you are reducing the search space, right, by half, right? So it's not computationally expensive. It has computational complexity of order of log n by 10, where n is the length of the segment, n by 2, right? Order of log n. Yeah. It cannot find complex roots. So this is true. It cannot find complex roots, right? It does not require the function to be differentiable, and it is guaranteed to converge if the inputs are right. If you get the correct intuition on the roots, it will always converge. So it cannot find the complex roots, right? So the correct answer is option B. B. It cannot find complex. Right? Anyone else? Do you have any doubts in this bisection method? If you have, please type in the chat box. Great. So let's move on to the next question. So what will be the output of the following snippet? So someone is asking, shall we discuss program about this? We have one problem where we will be applying the bisection method. So don't worry about that. So meanwhile, let's move on to the next question. What will the output of the following snippet? Let's solve this, right? So inside, so there is a function with main and every other things defined, and there is some code section of the code that we want to analyze what it does, right? So we have an array containing these elements, and I'm declaring a variables asterisk ptr1 of data type integer, right? So I'm saying in int asterisk ptr1. So everyone, are you familiar with the idea of this as these kind of variables where you use the asterisk symbol at the beginning? Yeah, these are what are these? These are called pointers, right? Pointers. So how does a pointer look like? How to declare a pointer variable? So you type the type name. So basically you type the type name, right? You write the type name, then one asterisk and the variable name, right? Variable name, right? So this is how declare how you declare pointer variables, what they do. So what they do is, let's say you have this main memory where all the data associated with your program is being stored. So let's call this main memory, right? So we all know that this main memory has some memory addresses. So let's say this starts from memory address. So it's on the RAM. So you all know that on the main memory, you have some memory addresses to store the values, right? So let's say this is value 100, 1000, and let's say each block stores 4 bytes, right? So this is 1004, this is 1008, and so on, right? Now, let's say I am storing some integer value at the memory location 1000, and the value that I am storing is 10 here, and it belongs to the data type integer, right? I am storing integer here. Huh. So I'm storing integer 10 here. So, and I am, so let's say I have a variable x that contains the value 10, and I'm storing x here, right? So x is stored here in this memory location. Now I'm saying int star, and let's call it ptrx, right? Pointer to x is equals to address of x, that is ampersand x, right? We all we all are familiar with this ampersand operator, right? In initial lectures, tutorial sessions, I explained this. So what I'm saying, I'm declaring another integer variable int asterisk ptrx, which stores the address of the variable x. So what this ptrx will store right now, anyone? It will contain the value 1000, right? It will store the value 1000, indicating that the value of the memory location at which this pointer points to is the address of the memory location in the main memory. The address in the main memory where this pointer points to is the value 1000, right? This is how we declare pointer variables, and this is how they are used. Everyone, is this clear? If this is clear, then only you can answer this problem, right? Great. So now, so this were so this example was pretty basic for some integer variable, right? Now let's move on to something different. So correct. Let's talk about collection of integer values. That is integer arrays, right? So when I talk about this array int arr, so when I talk about this array, right? So how it will be stored in the main memory? So it's stored something like this. So let's say this is our main memory. So red blocks indicate main memory. I'm not typing main memory again and again, right? Mhm. Char points, right? So this is a section of the main memory. So I have some bigger main memory here, and from there I have a block memory region that contains this array, right? So I'm expanding that block here, right? And let's say the addresses are something like this: 1000, 1004, 1008, 1012, and 1016. So these are the starting addresses in the main memory. And I'm storing the array ARR. So this contains the value 10, this contains the value 20, it contains the value 30, this contains the value 40, and it contains the value 50. So this is how my array will be stored in the main memory, right? This is what we know till now. So this is what we had seen till now, like, right? This is very clear to you guys, right? If you have any doubts in this, how the array memory is stored, array values are stored in the memory, then you need to look into the lectures of arrays again, right? Now the question is, what do we mean by this statement? int ptr1 of arr, right? int, I'm declaring a pointer variable ptr that stores the address to integer variables, and this is equals to arr. Anyone, can you tell me what this means? Anyone? So basically this value, whenever we talk about this pointer to arr, this is basically this contains the memory address of the starting, the first value stored in this array. So int star ptr will contain the memory address 1000, right? Yeah, right. It stores the address of array at index 0, right? So now this is clear. Great. So let's decode the second statement here, right? So let's try to decode this second statement here that says int star ptr2. So this was ptr1, this is ptr2 is equals to pointer 1 plus 3, right? Now, anyone, do you know what is the answer to this problem? This addition? So star PTR1 contains the value 1000 here, right? Then you are adding some value here, right? So should I add 3 directly here and get the address to 1003? No, right? It should be not 1003. Why? So this is where this data type of this pointer comes into place, comes into action. So whenever you are doing pointer arithmetic, you don't do normal arithmetic where you simply add the absolute values. Whenever we are dealing with pointer additions, right, like this, you add the value multiplied by the total memory location, memory space required by that type of variable. So for example, for integer, I am saying 4 bytes are required for storing one integer. So this value will become 1000 into plus 3 multiplied by 4. Why multiplication by 4 here? Because each integer data variable will be requiring 4 bytes, right? So, and I'm storing, so now this 4 will tell me that you need to jump by 3 into 4, total 12 bytes to reach to the next value memory address that I'm trying to refer to. So you will get this value as 1012. So this is where this data type declaration for this pointer variable comes into picture. So this integer tells me that you need to multiply 3 by 4 to get to the starting memory address of 10112. 12, right? So is this clear, everyone? This should be clear to everyone, I hope. If not, please tell me, I will answer this again. So how did I get 1012 here? So 1000 plus 3 should be 1003, but no, we are getting 1012, right? Great. So this is clear. Now the question is printf. So this is the final thing that we need to solve. We need to see, right? So let's look at this. The final statement says printf access specifier percentage d. So we are trying to print integer values, right? So this is the final statement that we want to decode. It says printf, right? And we use percentage d. So it is integer format specifier, right? And I'm saying asterisk ptr2 minus asterisk ptr1, right? Right? Asterisk PTR2 minus asterisk PTR1. So let's decode this. What do I mean by asterisk PTR2? Anyone? Now you know the value of PTR2. So what is the value of asterisk PTR2? Anyone? Star PTR2. What is this value? Anyone? Now you know the value of PTR2. Yeah, great. So this is equals to 40. So when you apply this star value, no, Rolly, there is a mistake in your, so let me explain this why it is 40 plus 3, na? Huh. Right. Yeah. So why it becomes 40? So whenever you apply this asterisk or the star operator to a pointer variable, it what it does, it dereferences it. So this is a dereferencing operator. It is acting like a dereferencing operator here. So you are dereferencing. So what do I mean by dereferencing? It means what is the value stored at the memory location that is held by this variable, that is stored the memory location referenced by this pointer variable ptr2. So you are dereferencing here, right? So to what is the value stored at this memory location, right? So you are dereferencing pointer 2. So pointer 2 points to the memory location 1012, which is basically storing the value 40 here. So you get 40 from here. Now again, so you are saying, let me, I will answer, come to your question, Damodar. Let me just solve this problem first. So now what is the second part here? So we can replace this. So yeah, so we can replace this part with the value 40 and we want to subtract some another value, integer value. Now again, what is the memory location that PTR1 points to? Anyone? PTR1 points to the memory location 1000, right? And the value at there is 10. So 40 minus 10. So what is the answer that will be printed on the screen? 30, right? So the correct answer is 30. So the program will 30. Right, everyone? Is this clear? If you have any doubts, please type in the chat box. Right, the output will be 30. Great. So I think no one has any doubts because no one is typing anything. So yeah. Damodar is asking what is the difference between asterisk pointer when it is on the left side and when it is on the right hand side of this assignment, right? So what is your question? So let me just ask, confirm once if this is your question. What are you saying? You are saying what is the meaning of int star PTR and int star PTR? Something like this, are you saying? Damodar, is this your question? So is the asterisk associated with the variable name or is the asterisk associated with the type name, right? So these two are same things. So these are two ways you can declare this pointer. So there is no difference. Is this clear? So you still have doubts in this? What is the doubt? What is the doubt? Uh, Damodar, please type in your doubts. I'm not sure what should I answer for your question. So there is no functional difference, right? Acha, something like this. Okay, okay. So this is not right question. Yeah. So you are saying what is the difference between, let's say if I have temp equals to asterisk at PTR plus I, and what is the difference between asterisk at PTR plus I, right? I guess this is an assignment problem. I won't be answering this, but I can give you an idea. PTR plus 2. Yeah. So from what this problem looks like, you so let's decode this. Like you have this expression. So let's look at this expression. Asterisk PTR plus I. So what are the operators here? The operators are asterisk, closing and opening and closing brackets, and one arithmetic addition operator. Which has the highest precedence, Damodar, among these? The highest precedence belongs to this opening and closing bracket, right? So first you solve the problem PTR plus I, right? Now what is this? Pointer arithmetic. You know how to do this, right? Now finally, let's say we have this value equals to PTR plus I, right? Now what I'm saying, I apply asterisk 12. What it is doing, it is dereferencing. So what it will return? It will return the value stored at this memory location asterisk. Is this clear, Damodar, in the first case? Now for the second case, what you are saying so for the second case, I hope this helps you. You can solve this on your own, right? So again, you split the left and the right hand sides and their expressions, and basically solve the second solution, second problem, second statement again using this operator precedence table, and you will get the answer, right? So just keep the operators separated out, and you will get the answer. Fine. Right. So this was question number 6. So everyone, let's move on to the next question. Question number 7. So anyone, do you have any doubts with point respect to pointers in this problem? Question number 6. I guess no one has any doubt, right? Great. So let's move on to question number 7. So we have to write a solution to the equation using the bisection method for up to 4 decimal places. So this is the problem where we will we'll be writing the program for bisection method, right? Consider the root lying on the positive coordinate only and compute the root till 5 iterations only. So I guess this is some assignment problem for you guys for this week. So I won't be giving the complete code program right now, and I will just help you guys with this problem, how to solve this, right? Right. So how to solve this problem? Again, I have already shown you guys how to solve these problems. So you have this initial points, right? Initial points are 1 and 1.1, right? So let's do one thing. Let's compute the values at these initial points. So what is the value at 1.1? It is 1.1 squared plus e raised power 1.1 minus 2 into 1.1 squared minus 1, right? The value you will get is 0.215041, 0.215041, right? The value lies somewhere here, 0.21, some positive value around 0.21, right? Now, what is the value of f of 1? The value of f of 1 is 1e minus 2 minus 1. So 1e minus 3, right? So f of 1. So it will become 3 e minus 3, right? So that will be approximately 2.7 minus 3, so minus 0.3, right? So the value will be minus 0.3. So yeah, so we know that our function goes something like this, right? Everyone, is this clear what I'm doing here? You know that the function has opposite values and these two at values of opposite signs at these two values, like, right? So we know that the root lies between these two. So how will you write your program? You will take the midpoint. You will find the midpoint m, which looks like 1 plus 1.1 divided by 2, right? Which is 2.1 by 2, which is 1.05. Now you will check the value f of 1.05. What is this value? Hmm. F of 1.05, it will be some negative value, right? This will be less than 0. So if this is less than 0, and you know that f of 1.1 is greater than 0, so you need to reduce the section in half, right? So now you have new point at 1.05. So this is the value 1.05. You discard the section behind, and you for sure now know that the function has a root between these 2 points, right? And then again you find the midpoint and again discard the half section and keep repeating until you get the answer, right? Anyone, do you have any doubts in this idea of this program? So I will not write this program for you guys because there is some assignment problem on this. I'm just giving an idea on how to solve this problem. Right, everyone? Bisection method is clear completely. No one has any doubts. Great. So let's move on to the next question. So what will be the output for this program? We have an array variable containing the values 10, 12, 6, 7, 2. Then I'm declaring two variables, integer I and as pointer p equals to a plus 4. Then right, let's solve this problem. So now we know how the array would have been stored in the main memory by now, right? So we will store 10 here, then we store 12 here, then we store 6 here, then 7 here, and then 2 here, right? So this is how the value will be stored in our main memory, how the array is stored in the bigger main memory, right? Main memory, and the array is stored like this in contiguous memory location. So let's say the array was stored in this section, right? So I've expanded this section for readability. Great. So now I'm saying we have a pointer variable star p, right? Asterisk p here. And I'm saying asterisk p equals to a plus 4. So we all know p equals to a plus 4. Now a contains the memory address or value 10. So let's say this was 1000. And we are talking about integers. So let's say they occupy 4 bytes. So these are starting memory addresses, right? 1016. So what will be the value P will be containing? It will be containing 1000 plus 4 into 4, that is 16, right? So this is equals to 1016. So the starting address is 1016, right? Now everyone, is this clear? P points at address of 2, right? Now what I am saying, for int I equals to 0, I is less than 5, I plus plus. So I am looping from I from 1 to 5, right? So this is where we'll try to solve, get our answer, right? So P is pointing to this starting address, and I'm running the loop from I equals to 0 to 5. So I equals to 0, 1, 2, 3, 4, right? This is how for loop works. I have to print the value. I am printf percentage %g, so integer format specifier. I'm saying I'm printing integers. P at minus I, right? So what do you mean by P at minus I? Anyone? So what is the value of P at minus I? So what is the value of P at 0? So this means what is the value at P at 0? We have to print this value. So I'm not getting this answer from anyone. No one is answering. So is this not clear, anyone? So I'm not receiving any answer. So P at 0 is the value stored at memory address P, the point where it is pointing. So the value stored at the memory stored it started at 1016. That is, so you dereference this memory address and you get the value 2 here, right? You get the value 2 here, right? So let's talk about P at 0 right now. Great. So it will give us 0, value 2 here. Now, what happens if I equals to 1? So I was 0 here. Now, if I is 1, now what happens? Let's see what happens. For I equals to 1, we are talking about P at minus 1. So how the compiler will, how the our C program will interpret it is, well, basically the compiler will translate it to. This means you have to dereference the value at the memory location starting at P, that is 1016, right? Minus 1. So minus index. So whenever you see this equation, so I'm writing on the left here. So whenever you see something like this, PTR at index I is essentially dereferencing the value. So I'm applying the dereferencing operator at the memory location PTR plus I, right? If you follow this rule to interpret the values, right? So this means dereference the value at the memory location 1016 minus 1, which is equals to the value at memory location 10, starting at memory location 1012. And what is this value? This value is 7, right? Is this clear, everyone? Now again, I equals to 2. You get p at -2, which is equals to dereferencing at 1016 minus 8. Oh, sorry, 1016 minus 2. So minus 2 basically means 2 into 8. So this becomes dereferencing at 1008, which is the value 6, right, everyone? Then you repeat this process and you will see that it is printing the array in reverse order, right? So you get the answer 276 12 10. 276 12 10. Option D is correct. Okay, -1 0 -1 -2 -3 -4, right? Yeah. So so one student has a doubt. So Dhanlakshmi, can you observe this equation here that I have written here? This is how the program will interpret any index reference to the pointer variable. Right, Dhanlakshmi, is this clear to you? Right? So now what happens if I equals to 1? I equals to 1, you access the value p at -1, which means dereference the value at memory location 1016 minus 1. And 1016 minus 1 for integer means 1016 minus 4, which is 1012. Right? This is the starting address I want to access. And you want to dereference the value stored at starting at that memory location, which is value 7. Right? Is this clear then, Lakshmi? A at I is usually asterisk A plus I, right? That's true, Damodar, you are right. But what if I is minus negative? You subtract the memory, right? Memory location, right? So this is how I'm saying. So you are right. This is how you access the values. Is this clear, everyone? Great. So yeah, right. So these were all problems that I had for you guys for this session. Now there is two practice problems that you can do on your own. So write a C program to add two numbers using pointers and functions, and write a C program to swap two numbers using pointers. Right. So you can do this problem on your own. The array indexing is like is use basically uses pointers at the back end. Yes. So now you can solve these problems on your own. Now, if you have any doubts, please type in the chat box, right? Otherwise, you can leave the session. I don't have any more questions for you guys to solve, right? So if you have any doubts, please type in the chat box. Otherwise, you can leave the session. So this was it for this today's session. Mhm. Yeah. So Damodar wants me to explain something about pointers. So yeah, let's see. So right, what are pointers? Pointers are specifically, pointers, variables used to store the memory addresses. There's declaration. For declaration, you already know. So you use type name, for example, int, asterisk, and variable name, right? For example, you have integer value a, contains the value 10 and you want to create a pointer to a, so ptr to a. So you have to use int asterisk ptr to a, and you can use the ampersand symbol to the get the memory address of this. So the next thing is dereferencing operator. Dereferencing means accessing the value stored at the memory location that the pointer is referring to, right? Referring to, and you can do dereferencing by using star ptr name, right? This is how dereferencing is done. The next thing is you all know, not by now you know about pointer arithmetic, so you can do it on your own. So I don't need to explain this. What are the application of these pointers, right? So we already saw arrays. So you need them in arrays. Then there are something known as linked lists that you will study hopefully in your data structures course. And these linked lists are really powerful and they are very useful in various cases, right? So then these are used to create trees data structure. So there is something known as tree that you use to manipulate data, that you use to store data. Then also you can store graphs using these trees, right? So these are some of the applications in of pointers, right? So everything basic that has been covered in the class is fine with you guys. I'm just giving some applications of these. So yeah, these are some data structures. If you search on the internet, you will see that these are really they use these pointers in the backend. Yeah. Anyone else, if you have any doubts, please ask or we can leave the session. So yeah, let's end this session, guys. Bye.